Alrighty, thanks, Ben. So today we're going to look at 5 different tips that I'll share with you about Azure Synapse Analytics SQL pools. We only have 10 minutes, so better get started, right? So the first one actually is something that you need to take into account. There are 2 really important concepts in Azure Synapse Analytics and as well in big data. So if you learn this in Synapse, you can take that knowledge to other big data systems. And it is data Skew and the shuffle data movement within Synapse. Just a quick reminder that when we got Synapse Analytics, there are a few new table types. One of them is the hash distributed, that it allows you to distribute the information based on a specific column across the different distribution hash. For those ones starting with Synapse, so Synapse has 60 logical storage distributions where the information is being stored. And then there are the other table types that we're not going to cover today, but this one is really, really, really important. And before we jump into the examples, also remember that with each tier performance level of Synapse Analytics, you get a different number of compute nodes. So depending on the number of data warehouse units, you're going to get a different number of compute nodes. So if you assign more power, so you get more compute nodes, right? And the ongoing cost as well is going to increase as part of that. So each compute node will be looking at different set number of those storage distributions. So if you have only one, it'll be looking at the 60 distributions. If you have 2, it'll be split across those 2 different compute nodes. So therefore, it's really important for you to monitor data skew. So data skew is the uneven distribution of data across those distributions. You can see in this example, so we have a table, that table has a lot of rows, and you can see how the information is not being stored evenly across those 60 distributions. And the challenge with this is that when you're working with one compute node, right? So that compute node is working with all the rows in all the distributions, which is fine. But in the moment that you start assigning more compute power and you have 2 compute nodes, now you can see how one of those compute nodes is looking at these 30 partitions. Remember, we have 60 logical distributions for storage, and compute node number 1 is looking at 74% of the rows, while compute number 2 is looking at only 25% of the rows in that table, which means that one of the compute nodes is doing more work than the other compute nodes. Therefore, when you are creating that table, the hash distributed table, it's really important for you to spend some time choosing the correct distribution key, the column that you're going to use to distribute the information across the storage. Right now, you are only allowed to choose only one distribution key. Potentially in the future, we'll be waiting for Microsoft to give us more options, like creating a table and being able to distribute the information by using different columns. But right now you are only allowed to choose one column. Really important. Then another concept related to shuffle data movement as well. Remember, so now imagine that you have 2 tables and they are hash distributed. So that means that you have selected a column to distribute the information in those tables, but you have chosen a different column for each table. And now you're trying to join those 2 tables information into a single query to get the result set. So that's going to cause a shuffle data movement because the information in one table is being stored using a different column than the other one. Just a quick reminder today, because we could go into detail with this. What you need to remember is that you want to avoid shuffle data movement operations, and you can monitor these operations. All the scripts, I'll share them in the resources. I'll put the links in the chat later for monitoring this. Second tip, actually, you have the replicated tables. So replicated tables is another table type, and it allows you to replicate the information of those tables in different compute nodes. So you're going to, if this table has 20 million rows, so you're going to replicate that table in each one of the compute nodes. What you need to remember is that to kick off the replication as such, so to kick off the job that replicates this information into this compute node, you have to run a select of that table after loading the information. That's really important. And if I can show you quickly with replicated tables, we'll go here. So I'll give you a quick example. So we're looking at this specific table. You can see that one of the tables hasn't been replicated across all the compute nodes. So therefore, you need to run a select of one of that table. Is this the way to do it? Is there a better way to do it? This is how it is. So to kick off the replication, you need to run a select of that table after. And now you see that the table is ready. So that means that information has been replicated across the compute nodes. Remember that to improve the performance. The third one actually is one related to statistics. So statistics they've been important forever since SQL Server, right? But with Synapse, we have to do some work ourselves because the statistics, they are created automatically in Synapse. And remember, the statistics, they help preparing the query plan. So the query plan is the steps that are going to be executed to return the result set to a query, right? So if the steps are incorrect, so the performance is going to be poor. And stats, they can be created automatically, but you need to maintain those stats manually. So what I'm suggesting is after you have worked, updated, inserted records into table, is for you to update the stats of those tables and to help the query engine to maintain those statistics. I'll show you a quick query now as well with the stats. You can see in this case, so we have this table and the stats they say that there are 99 rows and the actual rows in that table is 99, right? But what happens if I truncate the information of that table? And then I run the same query. Remember, no worries about the scripts. I'll share that in the chat. I share the links. So when I look at the results, remember we have truncated the table. Now you can see that the stats we have 1,000 rows, but the actual number of rows for that table is 0. So when this prepares the next query, the query plan, the performance might be affected. So what you want to do is to update the stats as part of your data movement processes, store procs, Azure Data Factory. So remember that updating the stats is really easy. And I do suggest to update the stats of the table, and that will update any stats that you have in that table. Really important. Number 4, external tables. So I remember creating a lot of scripts for creating external tables before, because external tables in SQL pools, they are cheaper to work with Azure Data Factory, for example, than using the copy activity. You need to write a few steps to create external tables, but now with the new experience of Synapse Analytics, you can easily go to your data lake, select the file that you want to create the external table for. You can see by just click over here and over there, not writing any code. This is going to create the scripts that we need to create the external table. See, I can see that we go to the dedicated SQL pool, DBO table sample, and using the T-SQL script, we execute this. I'm not even going to read it. Table example is a reserved word. DBO table sample. We create this table over here. And this external table is going to become available in your SQL pool while you're using Management Studio and all that things. I'm not going to review the script because we don't have time, but you get an idea on this. So the idea will be to do this here. The table is already created, and now we can use it, which is great. We can save a lot of money in Azure Data Factory, but by not using the copy activities. And the last one is caching, actually. So caching was one of the last capabilities included as part of Synapse. To use caching, actually, what you need to do is just make sure that it is enabled, and if it's not enabled, you can easily enable in your SQL pool. And one of the key benefits, actually, is that you can see that here I'm going to query this table, and we're going to see we're hitting the cache. So this information is being returned from the cache. So that means that even in this case, you can pre-cache some statements for your final users. So this information is coming from the cache. Even if I pick up, it's not coming from the database backend. So if I pick up this step, you see in the even here that is coming from the cache bit. So caching, amazing feature. It has some limitations and so on and so forth, but it'll get better as we go. And look, with that, we finished for today. There you have 5 tips and hints that you can use to improve the performance of your SQL pools. I'll be putting the links in the chat for the scripts, and I'll hand it over back to Ben.